Hello, my name is Karina Buka-Vaivade, and today I would like to present here research about behaviors of timber concrete composite members. Uh, Timber is a renewable material that makes a significant advantage for its use in construction, and concrete is the most widely used man-made building material. Timber concrete composite structures can ensure more efficient use of resources and meet the growing demand for sustainable structures. Combining such materials as timber and concrete can improve various classical disadvantages of wooden floors, such as dynamic reaction, bending stiffness, load-bearing capacity, sound insulation, structural fire safety, seismic performance, and heat mass, etc. Timber concrete composite enables to combine advantages of pure timber and pure concrete in one structural member, especially in the case when the rigid timber concrete connection is provided. As you can see on the slide, full composite actions provides much smaller deflections and provide concrete layer action in a compression zone only, in comparison with the cases when partial composite action with semi-rigid connections or no composite actions are provided. The adhesive connection of the timber concrete composite members is more effective in comparison with semi-rigid connections, so it provides high bending stiffness. But there is one important moment. It is difficult to predict the quality of the obtained connection with the classical production methods of continuous rigid connection when timber layer and precast concrete layer are simply glued together. And so the aim of the study is investigation of influence of the granite chips, which is proposed to use in timber to concrete rigid connection production on the behavior of timber concrete structural members subjected to the flexure. On the slide, you can see proposed production method of rigid connection between timber and concrete layers. It provides preparation of the timber base, applying glue layer of timber surface, gluing granite chips, and after drying of glued layer, placing a fresh concrete layer. To investigate the behavior of timber concrete composite, 4 types of specimens were prepared for laboratory analytical and numerical analysis. The first specimen was pure CLT panel with length 2 meters, width 35 centimeters, and height 6 centimeters. The second specimen was glued together, identical to the first specimen CLT panel, with precast 3 centimeters thick fine-grained concrete layer with strange class of C20. The third specimen was like the second, but with additional carbon fiber plate glued to the CLT surface in tension zone. Here you can see in the specimen carbon plate. And the first specimen type was identical to the third, but a rigid connection was produced by proposed method, which include the gluing of the granite chips on the CLT surface and then placing of fresh concrete layer. All the specimen was with 1.8 meters span and were tested in 3-point bending until the collapse. And here you can see comparison of the behaviors of the CLT panel obtained by experimental data and calculations, and of timber concrete composite panels, pure and with carbon plate, produced by classical dry production method and calculations. As it can be seen from the load displacement curves, at the load of 15 kilonewtons in the slab of pure CLT slab formed 28 millimeters large displacement. But in timber concrete composite, displacements are equal only 11 millimeters. So the concrete layer has a significant effect of the deformability of CLT panel. But as you can see, experimentally obtained curves for timber concrete composite obtained from bending test is characterized by less stiffness in comparison with analytical calculations and numerical obtained. Moreover, behavior of timber concrete composite with carbon fiber plate, which was produced by classical rigid connection method, is identical to the pure timber concrete composite. At the time, then according to the analytical calculations, bending stiffness of timber concrete composite with carbon fiber plate is almost 1.5 times larger than bending stiffness of timber concrete composite. The reason of this is pure quality of the obtained glued connection by classical dry production. Here you can see view of timber concrete composite panel produced by classical dry method, than when CLT panel is simply glued together with precast concrete layer after a concrete layer was collapsed. It can be clearly seen here that the qualitative connection was formed less than on 30% of the total connection surface. In this figure are summarized load displacement curves of timber concrete composite with additional carbon fiber plate in tension zone produced by classical production method and by proposed this one. With granite chips, these curves are obtained by 3-point bending test. And here is also summarized low displacement curves for timber concrete composite displacement obtained by numerical, linear, and non-linear analysis and analytical calculations. It can be seen that the timber concrete composite without granite chips develops much larger displacements than those obtained in the calculations. At the load level of 30 kilonewton, the experimentally determined displacement are equal to 23 millimeters, what is more than 52% larger than those calculated with 3D damage model. And at the same time, proposed production method, this one curve of rigid connection, provides full composite action of the spacement. And you can see also additional local strengthening of the concrete at a load level larger than 15 kilonewtons. The spacements with granite chips showed both higher load-bearing capacity as well as smaller maximal vertical displacements. The average destructive load of these spacements was 41 kilonewton. Then for timber concrete composite produced by classical dry method by gluing timber and precast concrete layer, a destructive load was only 32 kilonewtons. Maximal displacements at load level of 30 kilonewtons for timber concrete composite panel with proposed production method was smaller than 6 millimeters or 1/300th of spacement span. Strengthening effects what can be seen in this figure for timber concrete composite with granite chips can be explained by this figure because cement paste has worse strength than aggregates. And so granite chips as concrete aggregate locally increase the strength of concrete and which can absorb at the stage when non-linear behavior begins to develop in timber concrete composite by numerical analysis. Here you can see the strengthening effect. As a result of the research, the following main conclusions were obtained. Timber concrete composite allows to decrease such CLT problem as large deflections and provides more rational use of the strength of the material. Experimental results show that even with classical production of timber concrete composite rigid connection, concrete layer allows 2.55 times decrease mid-span displacements. The use of classical production method for rigid connection when timber layer is simply glued together with precast concrete layer is dangerous because it is difficult to predict the quality of the obtained connection. So it is not safe to predict the behavior of such timber concrete composite by models with the full composite action. The rigid connection produced by gluing of granite chips allows visual control of the glued connection quality and provides naturally developing of the bond between concrete matrix and granite chips as aggregates of concrete. Moreover, granite chips can provide local strengthening of concrete. By using of proposed production method of rigid connection between timber and concrete layers was obtained timber concrete composite with full composite action, which behavior is safe to predict by analytical or numerical models. Load carrying capacity of these spacements increases by 28.1% in comparison with classical produced timber concrete composite when materials are glued together without granite sheets. And mid-span displacements on the load level of 30 kilonewtons was almost 4 times smaller for proposed timber concrete composite in comparison with the classical one. So thank you for your attention.